It is the end of week 1. Congratulations, guys. We're going to start today with bell work. So head over and begin bell work. You're going to see these pop up on PowerPoints, and this is just for each unit that we have. There are certain things that you guys should be able to do, and so I put them in the PowerPoint so that you guys have access to or the knowledge of what's expected of you. Right now we are focused on getting everybody to understand number 3, basically how does science work. So what we are doing today is going to be writing in our science journal. We're going to be taking notes in our science journal for the first time. If you want that extra credit, a picture with your science journal is due today. You need a science journal anyways. It's always nice to get some extra credit thrown in. On the front cover should be your name, subject, astronomy, class period, and then hold it up and take a photo. So we are just going to jump in to our lesson today. We are learning how science works. Science works on observations. Ever since the first humans were around, people have been observing that things fall or that there are bright things in the sky. Certain animals are more dangerous than others. And when you make observations about the world around you, it's with your 5 senses. Now we actually have machines and tools that can go beyond our 5 senses. So we can see x-rays and we can, see with a microscope. So we have the ability now to go beyond our 5 senses, but it starts with our 5 senses, being able to see things, hear things, taste things, touch things, and smell things. So when you look at the world around you, what are some of the observations that you might make? Well, you look up and there are bright things in the sky, and you start to wonder why. So you make an observation and you come up with a guess or an explanation to that observation. And if that theory explains all of your observations, it's a good theory. And you should, if you have a successful theory, be able to make a prediction. And if those predictions hold true and your observations on those predictions hold true, then you end up going in this little circle that you see up on the screen. So you make an observation, something is happening in the world around you. You come up with a theory to explain why that is happening. And once you have that theory, that explanation that is backed up by observations, you can then make predictions. You can see, if there are going to be lights in the sky the next day. Do the lights in the sky stay in the same place? Do they ever change? So once you start making predictions, then you observe to see if those predictions are true. If they are, then your theory is kind of cemented a little bit more as being the correct way that the world works. So what is a theory versus a law? A theory is an explanation of what's going on. So there are lights in the sky, and that's because there are lightning bugs that live way up high. All right, so it's just an explanation of things that humans see. It explains the why things happen. So a theory explains why, and is based off, this is the important part, repeated observations. So you need to see something happen over and over and over and over and over again. It's not somebody's just random idea because they saw something once. So if you see something over and over again, and here's the word hypothesis, and you've done experiments that back up your observations, that is a theory. So a theory is something that has a lot of data, a lot of observations behind it. If you see new data, if you see a new observation, let's say you thought the stars in the sky stayed the same, and all of a sudden you see one that changes. Well, now you need a new theory. You need something better to replace your old theory. So as new observations, as new data comes in, theories can change, but it's always based on data. It's never somebody's guess. It's never somebody's, I kind of feel like this is the way it goes. It's based on data. So scientific theories are different than what people say in everyday English. All right. Theories in science have the most evidence to back them up. It's not somebody's, well, I have a theory of who killed John F. Kennedy, or I have a theory of, how many hurricanes there's going to be this year. You have data to back stuff up. Here are a few theories in science. Cell theory. Most of us have taken biology, have looked through a microscope, and have seen cells with our own eyes. That's an observation. That's data that you have to say that cell theory is correct. Theory of gravity. Most of us experience gravity every day. Theory of evolution. Every piece of data that we have says that evolution is how nature works. Evolution is how biology works. Germ theory. Diseases and sicknesses are made from or are transmitted through viruses and bacteria. If you wash your hands and you drink clean water, you're more likely to stay healthy. Those are all theories. If something happens one day and all of a sudden you drop a pencil and it doesn't fall, well, maybe something's wrong with our theory of gravity and it will need to change. But gravity has more evidence backing it up than almost any other theory out there. But it is still just a theory. So when you say the word theory in science, it is the most well-founded, most data-driven, most observations. It is the highest place that a scientist can put something as far as being correct. It's an explanation of how the world works. Here's a few other theories. Relativity with Einstein. Having our GPSs on our phones work depends on the theory of relativity. Plate tectonics, how earthquakes, volcanoes happen, why all of the continents look like a big jigsaw puzzle. Heliocentrism, the fact that the sun is at the center of our universe, of our solar system. That is a theory. That is the heliocentric theory. And the Big Bang, going back to how the universe began. There's overwhelming evidence that it began about 14.5 billion years ago, which we'll get into later this year. But that is a theory. If we get new evidence, we're going to have to change, how we view the universe. So a lot of people want to say, well, evolution is just a theory. It's just somebody's guess. It's just somebody who is making this up. I don't believe in evolution for one reason or another. Evolution is always the one that people get stuck on. Well, what I say to them is evolution is a theory. You are correct, but so is gravity. And if you're not going to believe in evolution, then you also shouldn't believe in gravity. And you shouldn't believe that cells exist. So this is a little meme that kind of gets to that point. What is a law then? Theory versus a law. A law helps explain observations. So a theory is an explanation of why things happen, and then a law just tells you how that is happening. Also supported by observations and experimentation. Oftentimes, let me find this. The law describes what is happening, not why it happens so much, but what exactly is going on. Oftentimes there is math involved. So Boyle's law has to do with pressure and gases and temperature. There's a math equation involved. It just tells you exactly what's happening in nature. It's not a theory of why gases exist, but it's a law of what's going on in the world. So you start off with things that you are explaining the world in. You can explain why things happen. You make a hypothesis and you test it. And if your hypothesis holds true, eventually, after enough data happens, you can come to a theory, which is an overarching explanation of how the world works. Laws are just telling you what's going on. They're just, this is nature, and there you go. So they are a little bit different. Now here's a question that I pose, and in class I would have people try to answer it. Can a theory ever become a fact, scientifically speaking? The answer is no, because if you get new evidence that is outside of your theory, then you have to change your theory. You can't have a fact. You can't have a theory that is a fact, because you can always get new evidence. Maybe your pencil doesn't fall, and so gravity needs to be changed. Gravity is not a fact. Gravity is a theory of why things are attracted to one another. So if you are going through in a science classroom, these are things to keep in mind. There's a lot of anti-science going around. With YouTube out there, with Twitter, with the internet, there's a lot of people who are very not good at science, who are making a lot of claims and claiming them to be true. My goal is for you guys to be able to identify which ones are correct, which ones are not correct. So if I'm going to look at a claim, is it correct? These are the things that I want you to focus on. Focuses on the natural world, so not ghosts and aliens. Aims to explain the natural world, not just this happens because of a demon does this. So there's an explanation behind why something is happening. It can be tested. That's the big one. It can be tested. A lot of people say the Earth is flat and there's a big wall, but nobody's ever been there to see it. It can't be tested, and they say it's being guarded by the military. And well, if you can't test it, you can't make that claim. You have to be able to test it. So explains the natural world, can be tested, and relies on evidence. It's not somebody's just guess. I think that Bigfoot exists. Well, do you have evidence that Bigfoot exists? So you need to be able to have evidence. It needs to be tested, and it needs to make an explanation of how the world works. Here's a few examples between science and what's known as pseudoscience, fake science. Science is willing to change. So if there's new evidence, science will change. Pseudoscience, this is the way it is, and no matter what evidence you give me, I'm not going to change my mind. Other experts in science will review the findings of other experts. They will make sure that they are doing experiments correctly. They will make sure that the conclusions that are being drawn are correct. In pseudoscience, they don't have anybody test their claims. It takes account of all new discoveries. So if you have, some scientific theory, and it will literally take every scientific discovery into consideration. Whereas pseudoscience is like, well, that one goes against what I'm saying, so I'm gonna ignore that one, and this one goes with what I'm saying, so I'm gonna focus on that. Science invites criticism. If you can criticize somebody's theory, well, that can make it better. So if you criticize somebody saying that the world is flat, well, now you're part of the global conspiracy that everybody is lying. So science is a little bit different than pseudoscience in that respect. Science has verifiable results. You should be able to do the experiment that any other scientist does. If you are pseudoscience, like fortune telling, you can't repeat your results. It's just it happens one time and that's it. Science depends on accurate measurements, whereas pseudoscience is like, it's close. It's not exact, but it's close. There's a number of differences between science and pseudoscience, and it's important to know the difference because there's so much just fake. It makes me sad sometimes. It really does. The Earth is not flat. Climate change is happening. Vaccines are not causing autism. There's a lot out there. So if you are making a scientific argument, you have evidence to back you up. You're making a claim, that can be tested. You are basing it on facts rather than opinions. And you are supported by data and observations and evidence. That is something that is going to help, back you up for a scientific claim. Now, what I would like you guys to do, I've done kind of my best to ramble my way through the difference between pseudoscience and regular science and what a theory is. I want you guys to read the article. It says Mr. Hyatt rocks. It is there, but it's also over on Canvas. So here is your assignment for today. Click here, and you have a choice, actually. You can read through this article, the difference between a theory and a law, or you can watch this YouTube video. The difference, basically the same thing. So if you want to watch a video, you can do that. If you're better at reading and having it in front of you, you can do that. And then what you're going to do is make a summary of whichever one you chose. So I would like you guys to fill out this little summary article, and that is what you guys are doing. This is due Monday at midnight. So today's Friday during the day. You have all weekend to think through this. It's due Monday at midnight on Canvas. If you have questions, please let me know.